5-9 today. It's slopes of parallel and perpendicular lines. As far as sections go, I don't think this is going to be a very tough section, so it'll be kind of a nice breath of fresh air for us. So slopes of parallel and perpendicular lines. And my guess is the slopes of parallel lines is going to be fairly intuitive. If you haven't learned it already, it'll probably just make sense. I do want to start with kind of going back a little bit. I thought it would help to look over that standard form, because the standard form thing comes back and kind of rears its ugly head in this section. So ax plus by equals c, we talked about this in maybe like section 2 or 3 or something like that. That when we have this thing here, that's just a line, right? Now here's the new part. I don't think we did this with, you could, if you wanted to write slope, you could just say m if you wanted to. I'm going to do, actually I'll do both. M equals the slope. When we did this section before, we said if you needed to find the slope, you could figure out 2 points, like figure out the x-intercept, figure out the y-intercept, and then do the slope equation, yes? That still works. If you want a shortcut, the slope is the opposite of a, or negative a over b. So an example would be 3x plus 5y equals 10. Okay, if I want the slope, that's going to be negative a over b. So my top of the fraction becomes negative 3, denominator is 5. So the slope is just negative 3/5 for that line. A whole lot faster than going through and doing it the old way. Now I can try to mess with your head a little bit and try to give you some negatives in there. That makes it a little bit tougher. So if you had 2x minus 7y equals 5, you could do that same thing if you're trying to find the slope. M is the opposite of a, or negative a over b. Anyone want to go out on a limb?
Negative 2 over 7.
Nice. Negative 2 over negative 7. So final answer? 2/7. Those negatives will cancel. We okay on those? So if you know that trick, that'll save you some time. So Roman numeral 2, I'm going to call it, is parallel lines. So Roman numeral 2, parallel lines. When I say parallel lines, can you picture them? Okay, so it's basically two lines kind of go in the same direction. So if this is one, correct. They could both be horizontal, they could both be vertical, they could both be on some funky angle like this here. They call it like an oblique line. So parallel lines, I don't plan to ask you to define it. I probably shouldn't say that because I'm pretty sure that's one of the I can statements. But it's in the same plane, so in the same plane. In other words, if I had a line that was like left and right on the floor below our feet, so kind of going left, right on the floor, and then I had one that was like up and down on the wall. You know, those are on two different planes, the floor and the wall, so they can't be parallel, even if they were both left and right. But they have no points in common. So have no points in common. So if we're looking at those ones that I drew before, these up here, they should just keep going for forever in both directions and never cross, so they have no points in common. Now really the key that they're trying to get to at this point is, what could you say about the slopes of those two lines? They're the same. And that's really the main gist of what we're trying to get at, is parallel lines have the same slope. So there's a chance I'm going to ask you to say what's in those blue things, but it's not real high. This thing in red, that's for sure going to be a big thing. The exception would be, what type of line has no slope? What type of line has an undefined slope? Yep, vertical, or up and down. So they have the same slope, or you could say they're both vertical. Another way to say that is they they have the same slope, or both of them have an undefined slope, being like a vertical line. And then
What's the in the same plane one?
the in the same plane would be like if you looked at one plane being the floor and one plane being the wall, you couldn't have a line that's on the floor be parallel with a line that's on the wall. It really doesn't come up. Probably more like if you're doing like hardcore geometry and like proofs in geometry, but I take that with a grain of salt. The first example I kind of already did, but I plan to say like just draw like parallel lines. So if you already drew them or you know it, feel free to skip it. But like that would be like an example of parallel lines. So one of the I can statements is going to be, here's one line. Draw a line that's parallel to it. That's the kind that you hope I put on the test. Those are the easy ones to get. The ones that are a little bit tougher would be the I can statement that says, are the lines parallel? Here's the equations. So in other words, like if I had like one equation being y equals 3x plus 4, and then my other equation I'm going to say is y minus 4 equals, I'm going to leave a little space there, x minus 2. As those are written right now, are those two lines going to be parallel? A lot of you are probably thinking like, huh? What's the only thing you need to check to see if two lines are parallel? Slope. The first line has a slope of 3. The second one has a slope of? No, there's nothing written in there, so it'd have to be a 1, right? You could put a 1 in right there and not change it any. Right now, they're not parallel, yes? These are not parallel because different slopes. So when you get the test question, I can see where it's kind of easy, or homework question, easy to be like, I don't know. And you look at the equations are ugly. There's one number in common, but really all you need to do is pick out the slope. What's the slope? What's the slope? Are they the same or are they different? Third example, and this here gets a little bit tougher. They say show this here is a parallelogram. So go with an object, something like this here. Show that is a parallelogram. If something's a parallelogram, what do you know about the opposite sides? They have to be parallel. So then what we'd have to do is we'd have to go through and figure out, well, what's the slope of each of those 4 sides, each of those segments. And then from there you could determine, is the slope of the top and the bottom the same? Is the slope of the left and the right the same? If so, it's a parallelogram. 3, 0, and -2, -2. So you could figure out the slope of the left side and the right side. Are they both vertical? If you look at this, yes. They have to be vertical on the left because x values are the same, right? This right side here, x values are the same. So we know the left and the right sides are both vertical, so they're parallel. Then we could get the slope of the top and the bottom as well if we wanted to. Should I work through and get the slope? I'm going to say this here's my x1, y1, x2, y2. So you could go through and do it like before. So we'd have a 5 minus 3 over 3 minus a -2. So we have a 2 over 5. So my slope of the left side, the slope of the top is going to be 2/5. So then the slope here is going to be 2/5. So the top and bottom have to be parallel also. Good?
Yep.
So Roman numeral 3 is perpendicular lines. So perpendicular lines. And the abbreviation for perpendicular lines is an upside down capital T, so something like that. Are you guys familiar with the abbreviation for parallel lines?
No.
Okay, maybe I should jump back up to the top then. So parallel lines, the abbreviation for parallel lines would be 2 vertical lines that are parallel. So kind of like 2 capital I's without the things on the top maybe or something. But, so parallel lines is that. Perpendicular lines, the T. The main thing to know for perpendicular lines is this here. the product of their slopes is negative 1. Oh, perpendicular lines are lines that form a 90-degree angle, right?
Yes.
I was kind of making that assumption. So they're lines that cross at a 90-degree angle. That's the official math definition. If you take the slope of one, take the slope of the other, multiply them by each other, you're going to get negative 1. Here's kind of the Falk version of the truth, the way that's a little bit easier to find one, is the slopes are going to be reciprocals of each other, but one has to be positive and one has to be negative. So slopes are reciprocals of each other with one positive and one negative. That if you learn it that second way, it's just a whole lot easier to get. And you could kind of see how, like if you have like the slope 1, if the first slope was 3/4, then the slope of a line perpendicular to it would have to be close. Yep. So you flip it, you do the reciprocal, you flip it, then you have to change the sign as well. So if the first one was positive, then the reciprocal is going to have to be negative. If the original slope was negative, then the second slope would have to be positive. Fair enough? So these would be two slopes for perpendicular lines. Maybe you could say slopes of perpendicular lines. Now the question that you're going to see is going to more be like this, and it's nice that it ties in the 5/8 stuff. This is the very last part of the notes. So I'm going to say example 4. And if you take it in small steps, I don't think it's very overwhelming. So write an equation for a line perpendicular. I'm just going to do a little perpendicular symbol. So write an equation for a line perpendicular to y equals 2x plus 4 through negative 2 comma 9. So write an equation for a line perpendicular to y equals 2x plus 4 through the point negative 2, 9. We had 3 line equations. I wouldn't write this stuff here in orange, but we started out the chapter doing this, ax plus by equals c. Then we did y equals mx plus b. Then we did y minus y1 equals m x minus x1. Which one of those line equations is going to be easiest to use if we know it's a line with a certain slope that goes through this point there?
Third one.
The third one. So if we take this third one, that's going to be by far the easiest. I'm just going to start, how I'm encouraging you guys to do it is just write out the generic one. If you're ever stuck on one of these questions and you don't write out this as a way to get you going, you're making a bad choice. So please, 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 write the thing out if you're not sure. But now, what can I fill in just knowing the point that it goes through?
X1 and Y1.
Okay, so x1 is going to be, okay, so in the parentheses I have a x plus 2, nice, because it's x minus a negative 2, so x plus 2, perfect. On the left side of my equals, I get a y minus 9, y minus 9, right? So now the only other thing we need to fill in is the slope, and the slope has to be, it's perpendicular to this one. What's the slope of this here in the green box?
So it's got to be 1.
Yep, nice. So this one here is the slope of 2, so we do the reciprocal. I guess it's too far out. Do the reciprocal, gives you 1/2, change the sign, negative 1 over 2. Make sense? That's really the whole section.